Hello and welcome to Best Management Practices. My name is Angie Corson. I'm the Streams Program Coordinator for the Missouri Department of Conservation. You are now watching the Best Management Practices talk. This is part of the Understanding Streams series of talks, and hopefully by now you have already gone through the other talks listed in this slide. If not, please take time to look at each of those, and I hope you enjoy this session. Best management practices are commonly referred to as BMPs. Best management practices are efforts to maintain natural functions of watersheds and their streams and to minimize impacts from watershed and stream alterations. So there are lots of best management practices, and one way to break them down is to put them into categories. Here's a list of 3 categories that I like to think about when considering best management practices. The first one is tools. These can be considered on-the-ground practices or tangible practices. Some examples are provided, such as detention ponds, tree planting, sewage treatment, upgrades, perhaps livestock fencing from streams, and the list goes on and on. Another category of best management practices would be knowledge. And this is just information and or education about things that may improve or prevent harm to a stream system or waterways in general. Examples of these would be pamphlets on the benefits of trees, maps of erosion-prone soils, education on water pollution, advocacy efforts, and again, the list can continue. And last but not least would be something we would consider as incentives, but these can also be disincentives. This would be more formal programs. So it could be either a carrot or a stick, depending on how you're looking at it. Laws and regulations oftentimes are considered to be a disincentive. So that might be considered as a stick, but they are very powerful when put in place in the proper ways. Incentives could be things such as grant monies going to, again, improve a sewage treatment plant or to help someone plant trees and set aside land in a very vulnerable zone. Um, Formal programs also include floodplain zoning that prevent certain things, construction activities and buildings from going in certain places that would cause damage if they were flooded and also cause damage to the floodplain and the stream itself. And you've probably all heard about places where they have banned plastic straws because of the pollution they were causing in the waterways as well. The best thing to know about the categories of these best management practices is that if you can use all 3 categories and aim it towards one purpose, it is a very powerful tool because you are giving people things they can do on the ground physically. You are giving people knowledge and education to understand and ways to learn and empower people. And incentives, again, can be providing help for them to be able to get out this information or to put in those tangible practices, or even a disincentive to keep people from doing things that would harm the natural environment as a whole and therefore people as well, oftentimes. So here is an example of combining these different categories. And it shows how using tools, knowledge, and incentives towards water pollution could be done from each of those categories. So if streams are being damaged by certain alterations, shouldn't best management practices be focused in the stream channel? Well, sometimes not so much, and there's a few exceptions to that. So when we're thinking about whether to focus the best management practices in the stream channel or on the landscape, there's a few things to think about. Aside from the in-stream alterations, so examples of that would be gravel mining or channelization, there's others as well. Almost all alterations that affect the channel occur in the surrounding landscapes or the watersheds. Therefore, a lot of times the most successful best management practices are going to be on the landscape or in the watershed at the source of that particular issue. So what is Missouri's #1 water quality problem? You probably guessed it. It's sediment or soil erosion. It's the #1 water pollution problem in the state of Missouri, and most of that comes, as I said, through soil erosion, off fields, off forests, off roads, all kinds of places. Iowa and Missouri data suggest the average erosion from cropland in Missouri is about 5.1 tons an acre per year. That's an enormous amount. It would take approximately 24 years to rebuild that much soil in a best case scenario, and we're losing 5.1 tons per year. As you can see, the math just doesn't equal out. We are losing topsoil way faster than we can replace it. So when we think about where the erosion is coming from, sometimes it's better to think where isn't the erosion coming from? Because as you can see on the slide, it comes from cropland, from pastures, from stream banks, feedlots, forest land, pretty much everywhere. So if we think back to one of the talks you may have already watched, the primary components talk, um, we're thinking in terms of that when we're considering best management practices because they help to rebalance those primary components to regain dynamic equilibrium within the system, in the stream channel, and in the watershed. So when we think about Lane's balance again that you may have seen in that talk, if you remember right, there was water, both quantity and quality. There was energy, which is slope oftentimes, sometimes volume of water. There was sediment sizes and the quantity of sediments in the stream. And then there was vegetation, which was a huge buffer for keeping everything else in balance, especially trees. There can be several objectives for best management practices. One of them would be protection. So this would be taking a system or an area that is already in good shape and just putting precautions in to prevent the degradation of that ecosystem in the first place. This is very cost efficient and very successful. Enhancement increases the quality or quantity of an existing, probably somewhat damaged ecosystem that you're trying to restore. So this can range in different activities that can occur here, but it's not a complete rebuilding of a system. This can be certainly more costly than protection is, but it is not as expensive typically as a restoration would be, which we'll talk about in just a minute. An enhancement has a lag time between when those practices are put into place and when the stream actually starts to recover. But again, it wouldn't be as long as a complete and total restoration. So restorations are where an entire stretch of stream or river or an ecosystem is attempted to be rebuilt to a close approximation of its former condition because it may have been so heavily damaged that just doing enhancement projects won't bring it back to the condition people want it to be in. So as you can imagine, these are typically much more expensive and they have a high risk of failure as well. There are long lag times associated with the recovery of these systems once they're rebuilt. So keeping people's expectations in line with what will actually happen is very important if a restoration is attempted. So for the purposes of the talk today, We have broken up best management practices into four different categories: rural, urban, floodplain and riparian, or in-stream. We're going to start by talking about rural best management practices. So why are they needed? Well, they're often needed to control erosion and sediment loss from cropland, pasture, timber harvest, also to control and manage animal waste and erosion from animals, and to improve water quality and the soil. You may recall from a previous talk that the unaltered historic vegetation in many places was either thick forest with briars and lots of brush and understory, or perhaps it was prairie with lots of very dense, thick prairie grasses and forbs. So when we think about changing that then to an agricultural or a rural situation where the land is being used, you can see that the vegetation component is quite different. I want to show you this slide now of a shoot where they're trying to demonstrate stream flow. And they put switchgrass, which is a native prairie plant, into this flume, and they are showing now the water that comes through the flume, and they add sediment so that we can demonstrate what it would have been like to have that thick of a stand of vegetation, whether it be prairie grass or other types of vegetation, controlling runoff from the landscape going into the stream. As we watch it, we're going to get a close-up of what is happening to the sediment in that water before it goes through the grass, or as it goes through the grass before it goes into the stream. Can you see how the sediment is piling up on the bottom of the flume? Even though the water looks like chocolate milk, that stand of prairie grass is acting to slow the water down, and therefore it's dropping out much of the sediment that was in the water, and therefore it won't be released into the stream channel where it could cause water quality issues. So one of many best management practices that are used in rural situations that attempts to do that same thing we just saw in the flume is using no-till when fields are being farmed. So this is where the ground is not worked and not tilled up or plowed under before a new crop is planted. And no-till allows for crops to be planted straight into the existing sod, or if there was a cover crop, it could be planted straight into that crop residue. And therefore, it keeps the sediment on the field with the vegetation and with good nutrients in the soil rather than releasing it all to the stream and thereby depleting the soil of nutrients it needs to even grow the crop. Contours and terraces are another tool that can be used to do a similar thing. And this is just by planting crops following the contour lines of the fields. If there's hills, making sure that they're going perpendicular to the downslope of the hill to capture runoff and silt and things before it can go downhill and eventually enter the stream. And it provides a barrier to keep all the sediment or soil in place as much as possible. Cover crops are another great way to try and hold soil on the landscape in the watershed rather than being released to the stream, and they are becoming increasingly popular. They're usually planted between the main crops, and it keeps things alive, plants alive on the soil, which is really good for the soil as well. And as you can imagine, then you don't have bare soil exposed through the fall, the winter, and the spring when we tend to get a lot of rain that can easily push bare dirt and bare soil off into the stream channels. Filter strips are buffer strips that are typically placed between the stream and the crop field. And they're small sometimes, sometimes quite wide. And they can be planted with different types of vegetation. And a lot of times people will stage the vegetation, starting with trees closest to the stream, moving to shrubs and bushes as they get further away from the stream, and then into perhaps native prairie grasses on the furthest point from the stream, but closest point to the crop field. And what this does is it allows that sediment to start being filtered out first from those nice, dense, thick grasses. Next goes through the shrubs, and lastly goes through the trees. The trees are typically better around the stream and on the stream banks because they have those strong roots that hold those soils into place along the stream channel that sometimes grasses do not have as much strength within their roots to do that. Another practice that's often encountered in rural areas is people wanting to harvest their timber for lumber products. And this is oftentimes a good management for the forest as well as for the production of wood materials for communities. However, there are ways to do it correctly and ways to do it incorrectly. Probably the biggest places of erosion in typical forest harvesting scenarios come from the hauling roads that are used. And there are lots of best management practices that can be used on those roads, including water bars that divert water from going straight down the road and releasing a bunch of erosion through the road system and diverts it back into the forest areas where it can be filtered first. There are other types of best management logging practices that can be used, and proper planning, maintenance, or the roads again are key to helping solve a lot of those erosion issues. And reseeding once that harvest is complete, both the roads and maybe even replanting trees in those areas can also help. There's a whole list of best management practices that MDC has on our website as well if you're interested in more information on that. Okay, as I mentioned, there's way more BMP types in all of these categories than we're going to be able to talk about. But we're going to move ahead and talk about some urban best management practices now. So, why are urban best management practices needed? Well, to reduce flooding and stormwater issues is one reason. To manage or protect infrastructure and manage costs is another one. And then to reduce heat islands and provide green spaces. And those are just a few reasons. So hopefully you've been noticing in these slides, on most of the slides, on the left-hand side, we are showing an altered condition that is not ideal. And the pictures on the right of the slide are typically showing the best management practice that could be used instead. So in this particular practice for urban areas, they're called bioretention areas. So where you would normally see long areas of paved surfaces that are impervious, which means they don't allow water to go through them, instead, it runs off at a very accelerated rate. If we have bioretention areas, these are meant to both slow down the water in place, but also sometimes collect that water in green spaces so it can be slowly infiltrated into the ground and thereby releasing sediments and pollutants and things that would otherwise enter the stream or even perhaps groundwater. So on the previous slide, when we were talking about impervious surfaces, they also make things that are pervious but are hard, so can be used on parking lots or even roads or sidewalks that can infiltrate water. And those sometimes are good best management practices and tools that can be used as well. In this particular instance, we're talking about phase grading, and that is when we're building houses, subdivisions, buildings, and oftentimes the practice is to go in and clear out an entire area, whether that's 100 acres or 5 acres or 10 acres at a time, and then just start constructing on the bare ground because oftentimes that seems very efficient to have the equipment there all at once and take care of things. However, if a best management practice to keep the soil where it belongs and to keep it from hurting the water is to phase grade, which means do one thing at a time, perhaps one house at a time. And even when that's not possible, do smaller areas and use all the erosion control techniques, such as silt fences. Oftentimes you'll see water bars that look like sandbags laying in the ditches of the roads as road construction occurs. So there are lots of tools available to still help slow the process of that soil erosion and preventing things from getting into the stream that could disrupt their balance. Another practice we often see in urban areas or neighborhoods is to concrete line what may have formerly been a stream channel or even a ditch or a little tributary. And what this does is it actually speeds up the water, as you may have seen in our previous talks, and makes it more erosive. And it also is higher in temperature and could have a lot of pollutants within it because there's no way it's being filtered and there's no natural systems involved in it. One of the ways that we can change this practice into something better would be to use vegetated swales instead. So it's still allowing a low place on the landscape where water can be diverted into to get it away from whether it's parking areas or houses or whatever it may be, but yet still provide the vegetation and the absorption that perhaps a tributary or a stream channel might be able to provide, and slowly allow that water to infiltrate both the soil and then eventually it rides slowly down slope towards a stream, even if it's allowed into a stream after that. That's a much better practice for both the water supply and typically for the neighborhoods around it, as it's not nearly the eyesore oftentimes concrete channels can be. Rain gardens are another best management practice that can be used in urban areas. And these pictures are actually from the office that I work out of in Sedalia. And when we started building this office, as you can see on the right slide, we have metal roofs. And even if we didn't have metal roofs, roofs are obviously impervious if they're working correctly. And they tend to allow a lot of runoff to come off the roof in through the gutters and quickly dissipate down through storm drains and storm sewers, which can be a problem for water treatment plants. And obviously, it's not good for the water because it's not getting anything removed from it as it goes down those very impervious places. So within our office building, we decided to install a rain garden, and these are commonly used in many areas. Kansas City has a huge rain garden incentive program. So the vegetation you see out in front of the finished brick building with the rocks around it was our rain garden that we installed. So it's multiple layers of different kinds of sediments, pea gravel, sand, you name it, dug really deep. So it's a very sponge-like quality in the soil. And then we planted native plants that are tolerant of water conditions. We also diverted all of our storm gutters on that side of the building to run straight into that rain garden. And it's amazing how much water is absorbed just through that rain garden. And unless it's a really fast, hard rain event, there's hardly any water then that ends up being released back onto the street in the sewer system. So it's an excellent way to both filter the water, slow it down, and retain it where it needs to be. An alternative to, or in addition to rain gardens, green roofs are increasing in popularity. And these are where the roofs are specially designed to hold the weight of soil and plants, and there's vegetation then planted on the roofs. And so they also help prevent like heat islands in big cities on major buildings, but they also continue to slow the rain and the runoff that comes off of those roofs. I mentioned this one a little bit earlier before. I forgot this slide was further down in here, but these are what I was talking about when I was talking about making impervious surfaces pervious. And these are permeable pavers. And concrete can also be made to be pervious. And again, the point is to slow the runoff and to filter the water and keep it in the soils instead of causing issues in the stream channels or in the storm sewer systems. Okay, moving right along now, we're to our floodplain and riparian best management practices section. So why are floodplain and riparian best management practices needed? One is to reduce flooding and stormwater issues. Another is to reduce erosion and sedimentation, as we've been discussing. And finally, to protect aquatic and terrestrial habitats and species. So originally, unaltered riparian corridors often extended from the stream banks through the entire floodplain of a stream system, going all the way to the uplands and then down through the largest sections of the river systems before they dumped into the sea. However, things have changed. Now it's very common, both in rural and urban settings, to see that riparian corridors near stream channels have often been cleared and are being used for other purposes. But best management practices are really valuable for both those areas. Riparian trees protect the stream banks from erosion, as we talked about earlier, both by slowing the water down and with their root strength holding those soils together against erosive and flood flows. They reduce overland water velocities, and they capture and store sediments and so much more, especially when you start talking about their value to both in-stream wildlife and terrestrial wildlife. Another best management practice in these areas would be called levee setbacks. So a levee is a berm or a hill that's typically constructed right on or right near a stream channel that basically makes the water have to raise a lot higher before it's allowed to enter the floodplain. So it may stop some small floods from entering floodplains or into areas where maybe there's housing or other things that need to be protected. But on major floods, oftentimes these levees are topped anyway. And one of the best practices for both the levees, the stream systems, and the floodplains is to actually set those levees back away from the stream bank as far as is feasible given the desired uses of those floodplains, obviously. And also allowing some of those forest systems and riparian areas and wetlands to reestablish within the insides of these levees. So from the stream up to the setback levees, so that they maintain more of their natural functions, which was to absorb that water, to slow that stream down, and it therefore has less impacts on downstream landowners than just putting those levees right up against the stream bank because it allows for a lot more dissipation of energy and other things to happen. So in these pictures, we can see that at one time, probably those levees were bordering that stream channel right along it. And it causes, again, lots of stream bed bank erosion and other issues, as well as disconnecting those natural systems from being able to function in the way that they used to be able to together as a community with the riparian zones, the wildlife, the wetlands, and the river channel. So by setting those back, sometimes as little as 100 feet, a lot of times 300, 500, it can go as far back as, again, is allowable. We allow a lot more natural stream functions to occur and therefore improving not only nature's habitats and communities, but oftentimes the habitats and communities of people both upstream and downstream of the levee systems. Okay, now we're to our final best management practice type, and that is in-stream best management practices. So, what oftentimes is overlooked is that stream channels are so connected to their surrounding areas. There's not just water running downstream through them. There's actually water running laterally back into the terrestrial landscape, longitudinally up and downstream, and then vertically, which is a groundwater component. So the stream beds, unless they're concreted with an impervious surface, they are permeable. And so there's a lot of interplay between groundwater and the stream water we see in the stream channels. And it's very important for those systems. So when streams are allowed to be connected to those natural surfaces again, they function in the way that they were meant to function, and they provide for lots of human ecosystem services as well. So on the left picture, we see a city that has a beautiful river running through it. However, as you notice, there is lots of impervious surfaces on that picture. There's impervious surfaces along the stream banks. Next to the stream banks is roads and buildings. And then under that stream channel, it too is concrete. So there is very little stream function occurring there. And when there's floods, there is nowhere for that water to be absorbed except for its neighboring infrastructure, which ends up being the buildings and the roads and the places we really don't want that water to go. On the right-hand side, however, we see a much more natural looking system as far as its ability to interact horizontally, vertically, and longitudinally within that stream system. So much more function is available to this system than to the one on the left. So when we think about things that can prohibit this connectivity that we are looking for in our stream channels, again, the last slide we talked about removing levees entirely or setting them back so that some function can be restored. Um, a lot of times if we can prevent floodplain development or intrusion, instead of going back and trying to restructure things after the fact, it's a much cheaper and much more effective way to handle floodwaters and storm issues. Another one that we often don't think about are dams or sometimes low water crossings that act as dams because they do not allow enough water to pass through them, and therefore they create a dam-like situation. So not only does this alter to some degree the way the stream flow can happen, but it can really alter the way that aquatic communities such as fish and mussel species can travel through that river system and have very natural ecosystems. They oftentimes present barriers so that species cannot get the gene distribution, the gene diversity they need because their breeding grounds have been limited. It also prevents them from fulfilling their normal life cycles of moving upstream at different times of the year or downstream different times of the year so that they can utilize more habitat to protect them. So it's very common also that our streams no longer have the same amount of water running through them that they used to. And we often refer to these as flow regimes. Sometimes streams actually have more water than they ever did before because there's storm drains being plugged into them. There's treatment plants that are pushing water into them. And so they've had to widen and readjust to those changes the channel does. And oftentimes there's less water coming to them, whether that's being diverted for public water supplies or used for irrigation or whatever the causes may be. And this too becomes a channel connectivity issue when we change the amount of flow that would normally be going into those stream systems and at the different seasons and rates that they used to go through. So that's another way that stream channel connectivity can be affected by alterations. So ways to improve that again is to set things back and to allow much more natural surfaces and corridors within those systems. So our Ozark streams in Missouri typically have a plentiful supply of gravel. And that gravel is often harvested to be used on roads and building materials and other uses. And when this is done properly, using the sand and gravel removal rules, this can be a decent practice and not have much effect on a stream system. However, when it is done improperly, it can have a very detrimental effect on streams. So typically a gravel mining operation will go within the stream banks of a stream and begin to mine off of gravel bars. Sometimes these bars can be vegetated and oftentimes they don't have vegetation on it. When following the rules of gravel mining, they really are to avoid areas that are heavily vegetated or vegetated with trees of substantial sizes. However, when there's loose gravel and that gravel meets the needs of the operator and they follow sand and gravel mining rules such as having a permit when it's a commercial operation, but otherwise following just the best management practices, this can be done with relatively little or no harm to a stream. So on the left, we obviously see an area that has been completely scraped, cleared, and in some degree probably very much altered and allowed for damage to that stream system because of the way it was mined. On the right, the cartoons kind of capture some of the best management practices, and that is to try to leave an undisturbed buffer of gravel along the stream channel of 15 feet, and then again along the area where the stream bank meets the gravel bar. And in doing so, there's a portion of that bar in the middle that can be excavated as long as, and looking at the picture below that, the excavated area doesn't become wet, which means that you're not excavating as deep as the water line in the channel. So if you were to dig a hole in a gravel bar, eventually when you would hit a point where water starts coming up in that hole, that's going to be the area that the stream channel is flowing at because it runs right through the gravel. So ideally, an operator, when they began to see a puddle of water forming in their excavated area, that's where they would stop, that level, and they could clear the bar to that level in that um, half donut hole of the bar and still not really cause much damage to that stream and allow them to use those materials that they've excavated. And probably one of the best management practices and most all-encompassing best management practices I would consider to be stewardship programs. These provide citizens with resources and support to complete hands-on stream best management practice activities. It also can educate them about stream conservation and water quality and enable them to advocate for their concerns for their communities, for their streams, and give their opinions on water in Missouri and the nation to people that are passing laws, regulations, and just informing their neighbors and their communities about the benefits of protecting our streams and watersheds. Um, you'll see the picture on the left, which I would consider to be an altered picture. That would be people sitting in offices, people looking at computers, people keeping themselves away from the natural world. And to me, the best management practice would be what we see on the right. We see children and adults alike actively engaged in nature, learning more about nature, and best of all, taking care of it. There's a trash cleanup in the picture on the bottom right. So people are talking and they're discussing the benefits of being in nature, and that's really important. So, from my standpoint, the more we can get people involved and engaged in understanding our natural systems and how much they benefit us, the better off we'll all be, and the more likely we'll be to pay attention to what we're doing that is altering our watersheds and perhaps hurting our streams. So thank you very much for watching this particular video in our Understanding Streams content. And if you have any questions, I encourage you to go ahead and contact us at the information on this slide.